Hey folks, this is Schatz. I'll help you set up 8.6. We'll make this a quick video. Here we have our numbers, and then we got to find the distance between A and B, and you can go right to LOC. On our next problem, I happen to really like this problem. Again, we're using triangulation to actually find people that are lost at sea. Here's all our numbers here. So what we have to first do is find out this big angle up here, and then you can use LOS. All right, on to the next problem. Sides of a parallelogram are 40 feet by 70, and we want to find the diagonal. So what we have to first do is find this large angle, and here's what I mean by that. Let me grab this. And you know something. If this small angle here is 36 degrees, whoops, let me try that again. And one more time. So in the parallelogram, this big angle down here is 36 degrees. That's a small angle. Here's the large angle up here. So you know something particular about same-side interiors of a parallelogram. So I like this problem because it does bring back some geometry. And then we have to find the diagonal. You're going to use LOC for that. Okay, and then we get down to here. Two planes are flying. It takes them 3 hours, but guess what? They're flying 450 miles per hour for 3 hours for that plane. And then this plane down here flies out 300 miles for 3 hours. So we'll call that plane A, I guess. And this one down here, we can call that plane B. So you want to calculate the red sides, and then you want to go after LOC. Make sure you go after the largest angle first. We get on to problem 5. And again, this is a real life example. I like these problems because it can relate to you guys. So anyway, here's this pole that's tilted 8 degrees over vertical. So now you know what this pink angle is. And once you find the pink angle, then you will be able to find this green angle up top. And then you could use LOS. But first, you're going to have to find out the pink angle and then also find out the green angle. We go on to our next problem. And again, we're finding the length of the pole. We go down to our next problem. And again, I know we're missing baseball. Some of you are baseball fans. And as you know, I don't care about any professional sports. But here's home plate here. And this is the batter. Hits the ball out the outfield. Here's where the outfielder is. He's 330 feet from home plate. But the ball goes 9 degrees out this way, and the ball ends up over here, which the ball traveled 420 feet, and they want to know how far did this outfielder have to run along this distance to catch the ball. So you can immediately use LOC. And we get on to our last two problems. Couple ways to do this. Here we have a 10-foot ladder, makes a 30-degree angle. Now we have a 20-foot ladder, and they want to know this angle here. So you could find this adjacent angle. Let me color it for you. You could find this adjacent angle here. And then you can use LOS because 10 is across from theta. This angle is across from 20. There you go, folks. And finally, we get to this one. Another, triangulation if somebody's lost. Here we have, what are these? These are two aircrafts, B and C, and a transmitter tracking station. So that angle between the two planes is 42. Here's 35 miles and 20 miles. We want to know how far the two planes are apart. So, folks, this takes care of chapter 8, and I'll have a little special assignment. We'll take an easy day tomorrow. I'm going to give you one problem for tomorrow, and I'll let you look at that. But that's it. This will cover Chapter 8, and we will finally be done. Have fun on these problems, folks. Please check your answers. Have a great day. Bye-bye.